Hello, and welcome to By Excellence Tutorials. If you happen to be in need of a physics or mathematics tutor, you can easily get in touch with me on the email or the WhatsApp line that I have dropped in the description box. For now, we can solve the question that is on the screen. Okay, so a 60 kg shell is fired with an initial speed of 120 meters per second at an angle of 38 degrees above the horizontal. At this highest point, at its highest point, the shell explodes into two fragments, one 3 times heavier than the other. The heavier fragment lands directly below the point of explosion. If the explosion exerts forces only in the horizontal direction, how far from the launch does the lighter fragment land? Okay, so we can illustrate this situation. So we can illustrate this situation like this. So my drawings are not going to be perfect. Bear with me, but I want you to get the concept. Okay, so we said this is the highest point where the explosion takes place, and then this fragment moves, and the other one moves like that, vertically. Okay. So this is positive X, and this is positive Y. Okay. So this is the how I can illustrate this. And then we have the angle 38 degrees, and this speed is 120 meters per second. And the mass for this is, the total mass is 60 kg. Okay, so this is how I can illustrate this. So now we can get started. So this question is not that difficult. You just have to combine the concepts of kinematics in 2 dimensions and also conservation of linear momentum, and you'll be able to solve it. Okay, so let's see how we get to solve this question. So now we have the initial speed, of which the first thing that we have to do is to resolve this speed, which is in the horizontal, we are going to have 120 cos 38, and in the vertical, we are going to have 120 sine 38 degrees. Okay, so what we say is in the axis 120 cos 38, which is equal to so we have 94.6 meters per second, and then in the Y, we are going to have 120 sine 38, which is going to give us 73.9. Okay, so that is our speeds in the X and in the Y. So now, the first thing that we need to do now is we can find the first distance, let's say X1, that was where the explosion took place. And then from there, we can find another distance, which we can label X2, that was covered after the explosion by this other, which is the lighter fragment of that shell. Okay, so now how do we can easily get the range, the first range, which is X1, but we need first the time that this shell took to reach the highest point. So now what we know is that the highest point, or the maximum point, the speed, the velocity is 0. the velocity in the vertical is 0. Yeah, it has stopped moving in the vertical direction. So the velocity in the vertical direction is 0 at the highest point. So we can use that to find time which it took to reach the highest point from the initial point. So we're going to use the equation of motion, which we have final velocity in the vertical equal to initial velocity plus gravitational acceleration time. Okay, so now we've calculated the initial velocity in the y, and our g is 9.81, so it's against gravity, so the gravitational acceleration is going to be negative in this case. So here we have a 0, and we substitute 73.9 minus 9.81 times time t. So when we group this, we are going to have 9.81 equal to t, and our time is going to be 7.5 seconds. So this is the time that this shell took to reach the highest point immediately, or the point where the explosion took place. So we can use this to find x1, our first range. So our x1 is going to be, we know that range is given by initial velocity in the x times time. So our range 1 is going to be initial velocity in the x is 94. We've already calculated that, 94. And the time, we have just calculated the time, 7.5 seconds. And then x1 is going to be 712.4 meters. So this is the range before the explosion. Okay. So now after explosion, what was this distance now? So how do we get to that? So we can first calculate this height. We can calculate this height. Okay, we can calculate this height and then calculate the time that this lighter fragment spent in the air. Okay, so allow me to erase something here. So I'll erase here. Okay, so what was the time? So how do we calculate the height now? So we also use the equation of motion. So we can use this one now, where we have the final velocity in the y multiplied by the final velocity, the initial, or subtract, should give us 2gh. Okay, so now what do we get? So what we have now is that initial velocity in the y for this lighter fragment is going to be 0, because after the explosion, this lighter fragment moves in the horizontal. Because we've been told in the statement, say, if the explosion exerts a force only in the horizontal direction. So meaning this lighter fragment, after the explosion, continued to move in the horizontal. So we are not going to have this component. Okay, we are not going to have this component. We are not going to have that component, and then we can be able to find, sorry, not this component. We're not going to have this component. I mean, the final velocity. We're not going to have the final velocity. So we have our initial velocity in the y, which is this one. So we have negative 73.9 squared being equal to 2, and then we have 1.81 h. So we want this height. So now this is going to give us okay, so we're going to have negative 5461.21 being divided by negative 19.62. So that will give us 270. Our height is going to be 278.3 meters. Okay, so that is the height that we've gotten. So now we can use this height to find the time that the fragment spent in the air. So now we know that height is given by density plus half gt squared. Okay, so now this second fragment doesn't have the velocity, the initial velocity in the y. It's moving in the x after the explosion. So this part is going to be 0. Okay, so we're going to have height being equal to half gt squared, of which this is going to lead to 278.3 being equal to half by 9.81 t squared. So we have 278 being divided by 78.3 being divided by 4.91. So our time, again, we have 7.5. Okay, we have 7.5 seconds. So this is the time that the lighter fragment also spent in the air after the explosion. So now from there, now we can now bring in the concept of conservation of linear momentum. So now, if linear momentum is conserved, we get to find what was the speed after the explosion of the lighter particle. Okay, so how do we solve that? So what we have is, sorry for, initial momentum should be equal to final momentum. That's what conservation of linear momentum is all about. So now, the shell of mass m with its velocity should equal to these ones. So we have m1 v 1 plus m2 v2. So this is in the x. This is momentum in the x. So what we're going to have is the mass is 60 kg in the initial stage, and the speed was 94.6. We calculated that. Okay. Now after the explosion, the heavier fragment, okay, lands directly below the point of explosion. So it doesn't have the velocity in the X. So here we are going to have 0. So it's 0. So now the small or lighter fragment, whose mass we've been told that we have one which is 3 times heavier than the other. So it means if the heavier particle is 3 times heavier than the smaller one, and the total mass is 60 kg, it means that the heavier one is 45 kg, and then the smaller one is 15 kg. Okay, so we have 15 kg times V2x. So we can calculate our speed now, which is 94.6 by 60 kg. We get momentum 5676 divided by 15 kg. Okay, so we now get the speed. So after collision, the speed of this lighter fragment was 378.4 meters per second. Okay, so this was the speed. So from this speed now, we had already calculated the time. We can use that time now to calculate the distance. So distance now is going to be the speed 378.4 multiplying by the time that we calculated 7.5. So x2 is going to be 2,838 meters. Okay. So that is x2. So for us to find the total distance, the total range, we just have to sum the first, which is x1, and the second, which is the x2, which we have calculated, and that will give us the total range that we are looking for. That will be where the fragment, the lighter fragment, is going to land. So we have 712.4 plus 2838 meters. So that when we punch, we get okay. So when we punch that one, we get 3,550.4 meters. So that would be the distance. This is how we calculate the distance. So if you've enjoyed the video, give it a like, share, give me some comments. And also, if you have not subscribed yet to the channel, kindly subscribe and hit the notification bell so that you get notified each and every time I upload a new video. Thank you so much for watching. See you in the next video.